Hello, today I'm going to demonstrate you how we're going to recognize pen expression automatically. This project is part of our final project in Ort Braude College, developed by myself, Elraner Billy, and my partner Arya Gaon. Well, the main goal is to test a theoretical claim that social cognition of pain in others is based on a fuzzy case-based reasoning process. Now, this is our program. And this system uses case-based reasoning integrated with a neural network in order to make efficient prediction during tracking. Now first let's open the tracker. As you can see here, we are using Visage Technologies SDK for tracking and extract action units from video frames. But in general, it can be any other tracking technology. Well, the first thing you need to consider when you deal with a neural network is what kind of dataset you're going to use for training. So we chose to take the AU's Visage offer us and build a dataset. I will show you now an example for how we generate the dataset. We're going to tracking. We will take some video to track from. Okay, let's take this. Now as you can see, tracking. And now, this is what we call the classification GUI. Here we go frame by frame and determine the pen measure for each frame. You see here in the slider below, we can set it to 0 or 1 for the most pen we can imagine. We can see here also what was the tracking quality and all the action unit values, the brawler, the eye, whether the eye closed, and so on. Now we click next. For this example, there's no pen at all, so we click next, then 0 for this case, then 0 again. We here have some pen here, so we will give this something like almost 1, then more pain and more. This is very painful. Click next. Now we finished. I will click OK, and then I can save this result into existed file. Let's choose the dataset just for example. And that's it. We just finished to add this result into the existing dataset. Okay, now that we have a dataset, we are ready for start training and create a new neural network. Let's go to the training section. Let us choose the dataset we've just created. Choose this for example. Now we have here activation function. We can choose the network type, let it be multi-layer perceptron. You can choose the training type, let it be backpropagation. Now I'm not going to dwell too much over all configuration here. Let's just put the values that we know that usually give an optimal result. Okay. Alright. Now the k-fold here is very important. We are using a k-fold cross-validation approach for training, which means we are separating the dataset into k subsets. Then we make k trainings and train new neural network in each training, using a different set as a validation set, while the rest use it for actual learning. So when we put here 4, we will have actually 4 networks. I'll choose one output neuron for pain measure. Here I'm taking 5 hidden neurons. We don't want too much and not too less. And 11 inputs as the number of action units we're using. Then we click train. Now let's wait till it finish. Okay, now we can see the result here. Usually we're taking the network with the most low training error, but we also need to consider the validation error. For this example, we will take this network. Okay, now I'm required to enter tag name. This tag will be used in order to save the neural network under this tag and the corresponding dataset we've just chosen. Let me just put example 1. Okay, the tag successfully created. Let's go back and see that we actually saved this tag. Alright, now let's get to business and see how the system is able to track and recognize pain. Well, this is the window here, the server window, that handles all cases processing requests and giving a solution using the hybrid CBL neural network system. The incoming request rate are currently about 4 or 5 frames in second. Let's start the server. Alright, now this window here is a demonstration window, and it is here just to demonstrate how we recognize pain. This person face over here will change to a higher level of pain expression whenever the pain measure result will rise during tracking. This slider over here will move also according to the same result, and the text area will contain the actual output numbers. Now let's start the tracker. We go over here. I want to open the demonstration window like this. Now let's click here, play, and as you can see, everything now is moving. The tracker is active and it's tracking my face. We can see that in a neutral phase we are almost 0 because there's a slight change because I'm currently talking. Now let's do some pain expression, and as you can see, everything here goes red. Let's try some different expression like happy, sad, anger. No, we'll not see pain here. Let's do pain again. Call the doctor. No, there's no need to call the doctor anymore. It can be detected automatically. Thank you very much, guys.